Lesson 8-6, simple compound and continuously compounded interest. When you invest money, you earn interest from the bank or institution in which you are investing. The balance of your account after T years may be calculated using simple interest, compound interest, or continuously compounded interest. Here are the three formulas that we're going to be using. It says recall that A is the current amount after T years, P is the principal amount, so the amount you're investing, R is the annual rate, interest rate as a decimal, and then for compounded interest, N is the number of compounding periods each year. So you can see there are some similarities. You have the principal amounts, and then one is using base E, so Euler's numbers, that's continuously compounded interest. So we're going to use each of these three, and we're going to be comparing the interest or the accounts with different interest rates. So Jeremiah invests $3,500 in an account with a 7% simple interest rate, making no other deposits or withdrawals. What will Jeremiah's account balance be after 6 months and after 1 year? So these are simple interests. So we're going to use A equals, we go back to that, the P times 1 plus RT. So again, T is the number of years we're going to have. So we have spot A, we do that down here. So A equals, the principal amount is 3,500 times 1 plus the rate as a decimal. This was 7%, so 0.07 times 6 months, but time in years, so this would be 0.5, so half a year. So on our calculator, we would do 3,500 times parentheses 1 plus 0.07 times 0.5 and parentheses, and we would get for 6 months, you would have $3,622.50. Now for 1 year, all I would have to do for 1 year, same equation, but I would have 0.07 times 1. So if I put in the 1 there instead of the 0.5, we end up with an amount of $3,745. Next, Declan invests $4,800 in an account with 6.3% annual simple interest rate, making no other deposits or withdrawals. What will the account balance be after 9 months? So 9 months a year, that's 9 out of 12. This will give us 3 out of 4, so 0.75 we'll use. So our account balance after investing $4,800 with an interest rate of 0.063 times 0.75 for 3 months, or 9 months of the year. So we have 4,800 times parentheses 1 plus 0.063 times 0.75 and parentheses, the account balance would be roughly, or will be, $5,026.80. Another, Clara invests $2,200 in an account with an 8.25% annual simple interest rate, making no other deposits or withdrawals. What will her account balance be after 3 months? So that's 3 out of 12, which will make that 1 out of 4, or 0.25. So our account balance, investing $2,200, 1 plus the rate of 0.0825 times 0.25. So 2,200 times parentheses 1 plus 0.0825 times 0.25. Account balance would be $2,245.38. Example 2 is now working with compound interest. Compound interest would be A equals P times 1 plus the rate over divided by not n raised to the nt power. So again, we're doing Elani invests $2,000 in an account with a 5% interest rate compounded quarterly, making no other deposits. What will her account be after 6 months? So that would be 0.5. So we'll put our formula in. So we have a principal amount of 2,000 times 1 plus the rate as a decimal of 0.05 divided by quarterly means 4 raised to the 4 times 0.5 years. So this is where I grab my calculator. Clear everything. So I'll type 2,000 times parentheses 1 plus 0.05 divided by 4 and parentheses raised to the parentheses. We got 4 times 0.5 and parentheses, and we get $2,050 and 31 cents. Now if we're going to do the same thing but for 1 year, I hit second, enter. Instead of the 0.5, I'm going to put the 1. Hit enter, and you get $2,101.89. Next, Molly invests $3,400 in an account with 2.8% interest rate compounded monthly, making no other deposits or withdrawals. What will Molly's account balance be after 2 years? So A equals 3,400 times 1 plus the rate 0.028 divided by monthly, that means 12 times a year, raised to the 12 times 2 years. So grab our calculator again, second, enter, change the initial amount. So this was 3,400. And the rate was 0.028. Delete that, divide by 12, raised to the 12 times 2, that's 24, so raised to the 24th power. Gives us a account balance of $3,595.60. This one is continuously compounded interest, so that we be using the PERT formula. Again, we're still using the 6 months and 1 year. So investing $1,800 times E raised to the rates as a decimal, so 0.045 times the time in years, so this would be 0.5. We grab our calculator. We have 1,800 times second division, base E, raised to the 0.045 times 0.5, and parentheses, gives us 1,840.96, so $1,840.96. For 1 year, go back to my calculator, second, enter. We'll make this a 1. Hit enter, and we get $1,882.85. Next, Mateo borrows $750 with an interest rate of 6.7%, so 0.067, compounded continuously, does not make any payments. How much will he owe after a year and a half. So that is times 1.5 on our calculator. Seconds, enter. This is 750 raised to the 0.067 times 1.5 and parentheses. That gives us $829.29. Antonio invests $2,600 in an account with a percent interest, so 0.06, compounded continuously after 4 months. So this would be times 1/3. So I'll grab our calculator. Second, enter. We have changed the amounts. So this is 2,600 times e raised to the 0.06 times 1/3. So 1 divided by 3. End parentheses, delete this last parentheses. And we would get our account balance of being $2,652.52. Example 4, we're now going to compare all the types of lenders' interest. Because here it says Tom wants to invest $1,800 at a bank that offers 3 different accounts. Account A earns 8% annual simple interest. B earns 8% interest compounded annually, and C earns 8% interest compounded continuously. If no other deposits or withdrawals are made, compare the balances after 1 year and 7 years. So this would be A, this would be your B, this would be account C. So for A, simple interest, this would be 1,800 times 1 plus the rate, 0.08 times 1. B would be 1,800 times 1 plus the rate, 0.08 divided by compounded annually, that's once raised to the 1 times 1. And then the other one would be 1,800 e raised to the 0.08 times 1. So for 1 year, grab our calculator. We have 1,800 times, this would be 1.08. That gives us 1944, so 1,944 for account A. For 7 years, do the same thing. I would now have to raise this to, or not raise that to 7, so 1,800 times 1 plus 0.08. Yeah, let me put the parentheses in here. So parentheses 1 plus 0.08 times 7 years. And we would get $2,808. For B, we have $1,800 times parentheses 1 plus 0.08 divided by 1 raised to the first power to give us 1,944. No difference for 1 year. Now we do 1,800 times parentheses 1 plus 0.08 divided by 1 raised to the 7th power. Here's where you see a difference. This would give us $3,084.88. And then the PERT formula for C, here we have 1,800 division raised to the 0.08. Let me put parentheses in here. 0.08 times 1. That would give us $1,949.92. And then for 7 years, second, enter, change this to a 7. And we would get $3,151.21. So comparing all of them, the compounding continuously would give you the better return for your investment. Next, Brianna wants to invest $5,000 for 5 years. She is considering 3 different banks. Bank A offers 5.1% simple interest. Bank B is 4.9% compounding annually, and Bank C 4.7 compounding continuously. If no other deposits or withdrawals are made, what would her investment be for 5 years? Which bank should she invest in for 5 years? So we have Bank A, we have Bank B, and we have Bank C. Bank A is simple interest, so this would be 5,000 times 1 plus 0.051 times 5. Bank B is 5,000 times 1 plus 0.049 divided by 1 raised to the 5th power. And the last one would be 5,000 e raised to the 0.047 times 5. So grab our calculators. First one, 5,000 times parentheses 1 plus 0.051 times 5 end parentheses gives an account of, move this over, gives us an account balance of $6,275. Bank B, we have $5,000 times parentheses 1 plus 0.049 and parentheses raised to the 5th power gives us $6,351.08. And Bank C, PERT formula, so that's 5,000 times base E raised to the 0.047 times 5 gives us a balance of $7,238.67. So Bank C would be a better place for her to put her money because it would grow at a more quicker rate. Example 5. Here we're going to use logarithms to solve equations. So Lorenzo invests in an account that earns 3.2% interest compounded semi-annually with no other deposits or withdrawals are made. Determine how long it will take for the investment to double. So this is compound interest, so we are using the formula A equals P times 1 plus the rate divided by N raised to the NT power. we need to double the amount. We don't know what the initial investment is, so we're just going to use the initial of 1. So doubling it would make that 2, equaling 1 times 1 plus the rate is 0.032. Semi-annually. Semi-annually means annually means 1, so semi means twice a year. So this would be 2 times t. So we're trying to find the t in years. So now we're going to simplify this. So now we have 2 equals 1 plus 0.032. 1 plus 0.032 divided by 2 gives us 1.016 raised to the 2t power. Now to do this, I'm going to find the logarithm of both sides. So log of 2 and then the log of this side. This will give me log of 2 for this one. Since I have an exponent, this can go in front. So I'm going to write that over here. So I have log of 2 equaling 2t times the log of 1.016. Get 2t by itself and divide by log of 1.016 on both sides. And then I'm eventually going to divide this by 2. So now on my answer, I'm going to have t equaling, and then I'm going to have whatever log base 2 divided by log of 1.016 times 1 over 2, which means I'm dividing that in half. So on my calculator, put this over. Okay, so here I have parentheses log of 2 divided by log of 1.016 end parentheses, and then I'm going to divide all that. I have to do one more parentheses and then divide all that by 2. That will give us 21.83. So 21.83 years is when Lorenzo's investment would double. And our last one, Jameson invests in an account that earns 1.8% interest compounded monthly. No other deposits or withdrawals are made. Determine how long it would take for the investment to be 50% greater. Round your answer to the nearest hundredth of a year. So it's not completely 2. So 50% greater would be 1.5 equaling 1 times compounded monthly. This is 1 plus the rate at 0.018. Monthly means 12 raised to the 12t power. So now I have 1.5 equals 1 plus 0.018 divided by 12 gives us 1.0015 raised to the 12t power. Find the log of both sides. Now if I write this, I have log of 1.5 equals 12t times the log of 1.0015. Divide both sides by a log of 1.00 or 0.015. And then I'm going to divide everything by 12. So on my calculator, I'm going to have parentheses log of 1.5 divided by the log of 1.0015 divided by 12. So we grab our calculator again. So second, enter, change some of these. So this is 1.5, in parentheses, divide that by log of 1.0016, end parentheses, divide by 12. We would get an answer of 21.13. I just realized I made made an error here. It's used the wrong decimal. This should be 1.5. There we go. So then we would get 22.54 years. That's our lesson on simple, compound, and continuously compounded interest.